So, in the previous video, you saw what each feature of the equation meant when drawn as a graph. Now, we're going to also use that equation more elaborately. Okay, what do I mean by that? Our graph is great. Okay, if you want, for example, to find out how much you make by selling, how much it costs to make 100 muffins, then you would just use the graph to read that value here. And from my count, it looks like approximately $250. That's what the graph is used for. And you could even question yourself, if you had $300, how many muffins could you afford to make? And the answer apparently here is roughly about 130 muffins. Okay, but there is one limitation to this, and that is the graph can only sketch reasonable values. Okay, in this case, it stops at 200. So what if the question asks you, what is the cost of producing, not a dollar value, but what is the cost of producing 1,000 muffins? Probably not so difficult in this case, because we know that if it costs $400 to produce 200 muffins, then 1,000 muffins would be 5 lots of 200, implying that you would take 5 lots of the $400 in cost, which is $2,000. But what if I said, I want you to calculate the cost of producing 7,250 muffins? Okay, now that is not a value that's on the graph, and I don't think there are any nice values on the graph that can help you find this. This is why we have the equation to help us. So the equation says that the cost of producing muffins is given by 1.5, $1.50 for every muffin we decide to produce, plus $100, which is our starting cost. So all we know now is that we want to produce 7,250 muffins. So we are going to say that N is going to be 7,250. So if you replace that in the equation, our cost becomes $1.50 times the 7,250 muffins we want to make, and on top of that, we have the $100 of our starting cost. This value comes to be 1.5 times 7,250 plus 100, $10,975. Okay, that is one advantage of having the equation over the graph. That is, when the values are too big and are not realistically graphable, we can use the equation to find out. Likewise, we can do the reverse. So I'm going to keep the graph here, not like we need it, but I'm going to say, if we have a budget, let's say $1,370, how many muffins can we produce? Well, the original equation had that cost was equal to 1.5 n for the number of muffins plus 100. In this case, I have prescribed for you 1370 as a value for C. So we're going to use the equation in reverse. This time we're going to replace a value for the money, which is 1,370, which is 1.5 n plus 100. Your previous work in equations will help you solve this at this stage. This is just a two-step equation with ugly numbers. The first order of priority is to move that 100 to the other side, and we're going to do that by subtracting 100 on either side. That brings you to 1,270 is equal to 1.5 to the n. Remember now that this means 1.5 times n, so to remove the 1.5 from the n, we will divide both sides by 1.5. And that answer comes to be 1270 divided by 1.5 as 846.67 rounded equals to n. Now, in a real life scenario, that means that you can only produce 846 muffins because your money or your budget does not allow you to produce 847. Okay, so I'm hoping this video showed you the benefit of having the equation, because the graph is limited to whatever's drawn for you. The equation will help you find or calculate any values you need to when the graph does not cover it.